Welcome to Command Shift Left, the podcast that helps you navigate the treacherous waters of the software development, ops, and security world while also diving into the hot current trends in the industry. Join myself, developer Philip, our co-host or Vice.
Hey audience!
As we battle through hilarious real-world stories, pro tips and hacks for navigating your way around developer security, learning about our Shift Left life, and life stories that have saved our ass. It's an absolute pleasure to be doing another episode here and to have another two amazing guests with us today, Nilesh and James. It's amazing to have you here. And in no particular order, let's start with short introductions from our guests. And let's start off with Nilesh. Nilesh, take it away.
Yeah. Hi. So I'm Nilesh. I'm the co-founder and CTO of Infraless. Before this, I have 10 years of experience in machine learning and infra, work with companies like Microsoft, Amazon. So yeah, that's a bit about me.
Awesome. Amazing. And James?
So I'm a software engineer. I've spent about half my career in test, half of it in development. I've worked in everything from Fortune 500 companies to startups. And right now I am the chief engineer and founder of Skymans, which makes a test automation product.
That's awesome. Testing is super important. You can never have too much test, at least written test.
Yeah.
Tests that you have to write is a completely different matter.
I couldn't agree more. And on that note, I think it's time to take it away with our first fact, and that fact is by Or. Or, tell us your fact.
Will do. So my fact for this episode is that a URN and a URL are a URI, but a URL isn't a URN. So for this episode, I kind of aimed for a more kind of trivia, more informative fact, just covering some basics that I find that a lot of people are confused about, and I thought it would be good to kind of set things in order. And but I'm going to try and test you and see if you folks remember how these things are structured. Well, let's start with what probably everyone knows, a URL. A URL is a uniform resource locator. It's basically a location. It's an address. It's what you type into the address bar when you have an API or a website you want to go to. And so without looking at the notes, who can tell me what a URL is comprised of?
I got nothing.
Wow.
Nothing.
Think about it. You type in the URL. What's the first thing that you type in?
I guess the protocol, right?
Protocol or scheme. You're correct.
Okay.
What's next?
Host.
Correct. 2 more points.
Oh, I got 2 points for that one. Oh, okay.
No, you got 2 points in total for the scheme and the host. Don't overdo it. But if you get 3 more points, you get a teddy bear.
Wow, that's great. Yeah, so I think it's sometimes also like a DNS instead of a host, where it's like a naming server that you reach out, like, right? Let's say Riverside or like something like that part of the URL, right?
So the domain name, right? Would that be it?
So those would be parts of the host. So the host name would usually be either a format of an address that can be an IP address, a DNS address, but it's in the end of the day, it's an address. And it might be comprised of different subdomains as part of it, but that's the host.
Mm-hmm.
What follows the host? Now you're setting up a server. Maybe it's a local server. What's next when you're running it?
The path.
What? Yes, there's a path, but what's before the path?
The port.
Port. Oh, okay.
Port.
Of
Well
course.
done. So I'll speed us forward. So we have the port, then we have the path. So the various slashes that build the URL itself. Then we have the query parameters. So you have the question mark and then a set of keys and values. And I'll just query you on the last one. What's the additional element that exists after the query? You also know this one, but
Would that be the anchor?
the anchor, or more correctly, the fragment identifier. So you'll have the hash sign and an indication of a fragment within the content, within the location. I do find it funny that this is something that we see, everyone sees, especially developers, but everyone sees this constantly all the time. But still, it's kind of hard to think about how it's structured unless you really put an effort into it. So that's a URL, and both a URL and a URN are part of a URI. So a URI is built out of a scheme and then the resource identifier. So, for example, in the URL also it starts with the schemes like HTTP, but the scheme can be anything. It can be Postgres, it can be Redis, it could be
TCP. Yeah.
exactly. And with a URN, the scheme would start usually with URN. And URN is a unified resource name. And we see that a lot with working, for example, with resources in AWS, and where we're working with solutions like XML or SOAP. You have all of these schemas defined in URN, and URNs will start with URN, then the namespace identifier ID, and the namespace specific string. So that will be a string that is usually delimited with colons, kind of defining the hierarchy that this resource is constructed of. And as I said, both a URL and a URN are a URI. So now we know. And
You
I
mentioned-
want to follow. Oh, go ahead, James.
You mentioned SOAP. I've got some experience with SOAP. I always thought it was weird that SOAP used URLs for their namespaces.
I always thought that it's weird that SOAP wasn't extinguished and destroyed on the day that it was created. It's an abomination of hell, and the fact that people brought it upon other people is a crime against humanity, as far as I'm concerned.
No disagreements here.
I had to write a lot of code for SOAP back in 2011, orchestrating VMware vSphere, and it was definitely one of the worst experiences I had as a developer throughout my career. And think about it, it's back to 2011, so a lot of water has gone under the bridge, and this is still torments and haunts my dreams. What about you? Are there other scenarios where you worked with URNs or URLs that have left a dramatic mark on your psyche?
Well, I mean, depends on what you mean by dramatic. Certainly not bad. But regrettably, the product that Skyman makes actually does use SOAP, because it was started back in 2012, and that's what was prevalent at the time. So I feel your pain when you talk about having to use it.
Yeah, but it sounds like you've kind of maybe you were just more robust, more durable as a person, so you came out less scathed than I did.
Well, I limited its effects, I guess, and also I've enhanced it so it now properly supports JSON over HTTP as well, so I don't have to use it anymore. So
when did that innovation kick in? Like 10 years ago, 5 years ago?
The JSON?
Mm-hmm.
Actually, fairly recently. It was probably about 2 or 3 years ago that I finally added support for that.
Wow, that's very recent.
Yeah.
Considering the 12 years that have passed.
Yeah.
Nilesh, how about you?
Yeah, so I think I've been one of the lucky ones. Never got to deal with SOAP. I think earlier started with when Amazon and other companies, we were mostly on REST, and I think it's also very very hard to understand REST also, right? To keep it stateless. So that was something part which was a learning. But yeah, I think having said that, right, REST is still a breeze, and the communication protocols were very simple and straightforward to me.
Yeah, weirdly, I even recall SOAP. I recall being forced to learn it at university as part of learning about SMTP, the mail transfer protocol. But luckily, I don't remember much more. So clearly, I wasn't very interested, or luckily, we weren't taught that much of it.
Just block it out of your brain. You'll never use it again.
Yeah.
Cool. I think this is a perfect moment to move to our second fact for this episode. And that fact belongs to James. James, take it away.
So my fact is that build pipelines make very poor test automation tools. So I mentioned earlier, I spent about half my career in test and the other half in development. And every single company that I worked at in a test capacity, and I've worked at several, like over a dozen now, I have had to build my own test automation system. And that's meant either building it from scratch or building it on top of something like Jenkins. And both ways suck, honestly, because, I have to build it, I have to maintain it, I have to extend it, and I never get the time I need to put in all the stuff that I want. So, like I mentioned back about 2012, I got fed up with that, and I started working on my own test automation system in my nights and weekends. And so that's what the product is called Smart, and that's what Skymind now distributes, and it's actually available for download for free.
And James, how do you think about the Gen AI impacting testing? So I think that's something that we, at least at our team at Influence, have been experimenting a lot, right? Because again, everyone hates writing tests, but everyone wants a lot of tests. So that's always a wishful thinking. So I would love to hear your thoughts on that. Yeah.
I think it'll be a while before we get really effective at writing good test cases with Gen AI, because Gen AI has the same problem with tests that it does with development, which is the hard part is taking the requirements into an implementation that can be meaningful, right? And so for testing, just like development, you have to understand the thing that is being shipped, being delivered. And, Gen AI is not there yet. It's great at writing parts of programs, I think. Although my own experiences have been frustrating because it keeps getting it wrong. But, it's not at the capacity yet to understand what it is you're trying to do and do a good job with it.
The hallucinations part with AI is really what keeps you on your toes, especially with something so sensitive like tests, which can break your understanding, your monitoring, and your basically health checks of your entire system. I'm thinking of experimenting with an approach of going from basically end-to-end tests that will kind of vet initial tests or in code created by AI, and then gradually moving into the more applicative tests and unit tests. I'm still confident that I'm still adamant. That's more correct. I'm still adamant that a human would still ever have to go over the generated tests, but I'm kind of hoping that process of going from the overarching and zooming in will reduce the amount of hallucinations that are tossed at you. But I think this entire area is kind of both cutting and bleeding edge.
Yeah. Would you think that AI would be good enough to, rather than maybe writing the tests, to generate all the testing scenarios that you might need based on the use case? Do you think it would be good at doing so? Because it feels like there's so many different ways to think about a use case, especially with end-to-end tests. Would then AI have the ability to understand that amount of information, or just that amount of specific use cases?
I think right now, probably most AI can't. I think what it would be good at is, if you can give it an API and, give it the parameters that, you're expecting from the function call, I think it probably would be very good at generating different variations of executing the API calls. And you could probably get a lot of coverage just from that.
Yeah. No, I would like to
say that. The AI can definitely generate. Oh, go ahead, Nilesh. Sorry.
Yeah. So I think I totally agree with the scenario which James described, where I think if you give it the constraints and the functional code, I think within that constraint, the PNC generation is pretty effective. And I think that's the part where developers really write to hate. Let's say, hey, if I change this parameter and then write the test again, change two parameters, what are the different PNC of tests that we need to do? So I think that part is especially useful now also, where we have seen even the GitHub Copilot or the ChatGPT-4 are able to generate a lot of good unit tests. I think it's definitely limiting at when it comes to integration or thinking about talking between systems. But I think for a unit test, I definitely see it getting really, really good, really, really fast.
I feel that like the challenge with tests is not actually covering all of the area. It is some part of the challenge, but I think the more significant challenge is having tests that are indicative. Like if this test fails, I know what's wrong with the system. I know what regressed. I know what changed. I know where I need to go and look at. And if you just, okay, I have a test for every scenario and they all blink in and out in a kind of a uniform manner, it doesn't communicate to you as an engineer what you want to focus on. So you can't have like just a lot of tests and all of them are on the same level of importance. You want to design your tests so they communicate the state of the system to you. And I think that requires, first of all, an understanding of the overall architecture, not just the code that you're looking at, but what this thing is connecting to as a system. And also the thinking of an engineer of, okay, how am I going to maintain and work on this thing? And as you get to these more broader areas that have a lot of forward thinking that you need to do, there's also a lot of more room for the AI to hallucinate things. So I feel like we're not quite there yet. Probably we will be there and probably faster than we expect. But for now, I'd be kind of hesitant to let AI just create all the key tests for me, because also another part of it is the AI created it and I don't necessarily understand how it was created and what was the intention for it. And that's also something that will be kind of hard to communicate.
I think also you have to think about, when I'm thinking as a test engineer, I have to put my thinking cap on, like, how would I misuse this, right? And it's not a simple matter of, just calling a function with different parameters. I'll give you a perfect example. I had a crash the other day, and it involved two functions, and both of them by themselves worked fine, right? So all my unit tests were passing, right? But it turned out that if I alternated them back and forth a couple of times with the same object, that I'd get a crash. And it's like, how do you possibly foresee that, right? I mean, everything that you thought of, is working fine. I think an AI would too, right? Because it's going to be focused on the individual APIs. But it just so happened that in this particular case, there was some strange interaction.
Yeah, and these are the worst bugs also to solve. All of these Heisenberg bugs and race conditions, and where joint resources and multi concurrency locks affect one another. Like, I'm guessing that like intuition and experience point me kind of in that direction, and I'm not sure that AI would have that intuition come in as easily in both in writing the test and also looking at their potential outcomes.
James, did you only notice that bug once you've tested it several times? Is that the case?
No, unfortunately, this made it into production. And so I noticed the bug when I clicked on a link in the web service and the server crashed. So fortunately, I've got very good test logs, and I got a very nice stack trace of, where it crashed. But then I had to take that and then just trying to experiment to like, okay, what was the exact set of operations that caused this?
So, James, so the tool that you shared, Smart, how much of these gaps do you feel the tool helps with?
Well, Smart is a test automation tool. I mean, you can find it at skyman.io. And it allows you to run your test in ways that are helpful in a distributed way to get a lot of coverage very quickly, and get good data, get good reports, get good analysis. But it doesn't understand what it's testing, unfortunately, right? So the burden of writing a good test case still falls on an engineer. Now, Smart frees up the engineer so they don't have to write all the test automation stuff anymore. But somebody still has to have an understanding of, what this thing is doing and how it should work or shouldn't work.
Makes sense. And now that we have some more additional sense, I think we are better equipped to move to our third fact. And that one belongs to Philip. Philip, take it away.
All right. So as always, I'm coming with the quirky and slightly different facts that hopefully will make you guys think, not just our guests, but also everyone listening to this podcast. And my fact for this episode is that in 2021, scientists at the University of California in Berkeley developed a revolutionary type of electronic skin. And as you can imagine, they called it e-skin, that can heal itself and is recyclable. Now, this e-skin is or was made from a very thin, flexible material that had a bunch of embedded sensors within it that could detect things like pressure, temperature, and other stimuli. So as you can imagine, it really behaved like something very similar to what we're familiar as our skin. Now, what was remarkable about it is that this e-skin had the ability to self-heal at room temperature in just a few minutes when it was damaged. And additionally, this e-skin could also be fully recycled, which is obviously another interesting part of it that, obviously is not like our skin, or in some way, realistically, we can self-heal as well. So it really matched to what the actual real human skin is like.
You can also be recycled. I would.
Well, I guess. I guess in certain case scenarios, although that would be very strange.
I'd say in all scenarios, we put you in the ground and you're recycled.
Okay. Yeah, well, yes.
That's you wanted to say something?
Yeah, I wanted to understand, like, what would the recycling part even mean? Like, let's say when you're done with your skin, someone like other can like put it on and like.
Well, I assume what Or meant is like when you, for example, kill a boar and then you can skin it and put it on your wall. Maybe someone would want to do that with human skin. I don't know.
You can break it apart and reuse.
So there was a process.
That's what I define as recycling.
True.
There was a process. I guess it's probably still in use, where they could manufacture artificial skin. And they were using it to help soldiers who had experienced burns in their skin. And it was just like regular skin, except it did not have hair follicles.
Mm-hmm.
And the way that they made artificial skin was they would get a skin donor, and then they would run it through a process where they would multiply the cells over and over again. So in that sense, your skin could be recyclable.
Yeah, I guess so. Actually, one of the cool implications here for which they made the sea skin was to offer it as a use for prosthetics. So obviously, in that way, I guess it would also be replacing some skin of a human. But it was also used for robotics. So I assume when they create the very futuristic robots, for them to be very much more human-like, and for them to be able to feel things like touch because of the amount of sensors that they may have. But then again, which kind of led me to think, in regards to the sensors and what they can put in this skin, what other types of sensors could be integrated into this e-skin in the future, and how it could potentially help us. Kind of very dystopian here.
Yeah.
My first association here, by the way, I'm guessing most people in the audience my age would have the same association, is Terminator, like T8R T1000, like with their metal skin on top of their skeleton that has essentially these qualities. Thinking of this combined with the rise of AI, I'm basically thinking of Skynet, and I, for one, welcome our new overlords. Well, we're in consensus here. In terms of what sensors I'd add to the skin, first of all, I'd make sure that it has all the basics. Most artificial solutions today, including replacement body parts, don't have most of the sensors. They don't have actual fine-grained touch. They don't have fine-grained temperature, motion, etc. So I'd start with the basics, actually. And but once that's covered, I think I'll go into communication. Like if you could touch other devices and communicate with them directly, but not by clicking, but actually maybe kind of like RoboCop, like if you stick something into the system and you're directly connected, I think that would be pretty awesome. I'm annoyed, for example, IoT devices, how cumbersome it is to kind of wait for the app to load, click on it, etc. So that will be cool.
Yeah, I think sensors also, I think that can probably like integrate with our screen. And I think there's this whole industry of like wearables, right? Where we want to capture our like blood pressure, temperature, even like blood to glucose level, right? So I think that's also, I think if that can come as a sensor, right? Where you can just like patch something on your skin and it's organic and it doesn't need like a power source. I think that would be also pretty fascinating, like things that this sensor can probably add, right? Where it just like, I think USB port is also like a great idea where you can just like, if you want to download like a movie, you can just like plug into your iPad and then that's also like sounds pretty cool. Yeah.
This combines well with the fact that we have on another episode with storing information in DNA.
Yes.
So for the audience, if you're interested in that, go and find that episode and it. Well,
did the people who made this artificial skin, did they say anything about the possibility of generating electricity with it?
It hasn't been mentioned, but it has been mentioned that well, first of all, like I've said, that many sensors could potentially be embedded into this. So I assume if they can embed sensors, they can probably embed other things for generating electricity. How are you thinking about it?
I just, I'd like to plug up my iPhone to myself, right, and just charge it
Your
while
finger.
I'm walking around. Yeah.
That would be the perfect diet. Like, a lot of people have a hard time finding the motivation to exercise, but like if they need to do so to watch the next episode of their favorite show, they might be more engaged to do so.
There you go.
As a teenager, I had an idea for a device you could wear that would do photosynthesis for you and actually provide sugar molecules directly into your bloodstream. In retrospect, I think that's a very dumb idea because, at least in Western society, we have the complete opposite problem. We need to get the sugars out of our bloodstream,
Yeah.
opposed to into it. But so maybe reversed photosynthesis, like you have a flashlight essentially, or you grow plants on you. That will also be cool.
If it could produce oxygen for you, that'd be pretty cool.
Yeah, that'll be good.
I mean, we exhale a lot of carbon dioxide. If we could also, take that and just translate it straight into oxygen again.
Yeah, negate your own carbon footprint.
There you go.
Yeah, that kind of makes sense. I'm not sure the math would work out with like a surface area, but it is interesting to explore. We also have another episode where we cover how you calculate your carbon footprint and the carbon footprint of your application in the cloud. So it's another good reference point for people looking for more episodes.
And I think on that reference point and the teasers to the other episodes, which our listeners unfortunately have to find because we just never name the episode number.
That way they listen to more episodes.
Exactly.
Right.
Exactly. And on that note, I think it's the perfect time to move on to our final fact. And that fact is by Nilesh. So Nilesh, take it away.
So I think the fact that I want to share is like how Kubernetes and the like DevOps platform are like built in a fashion with compute at the center, and now like with the advent of machine learning, right? How much data needs to be in like center for it, right? So just to give you a little bit context, right? If we see like the 1.0 code, right? Code was typically in like MBs, and now it has become like these model sizes are in 50 gigabytes or even more, right? So it's really fascinating how like that needs to change the whole approach of like DevOps, because I think Kubernetes by design was meant to be stateless. And I think that's like a very limiting architecture I feel about is like about deploying ML models with that.
We so the recording got you, but we got only fragments of what you said because you had some lag there. So we'll fix this in editing, but maybe give us a quick recap of your fact or respond to.
I think just a quick recap of the fact. So again, it's very fascinating that how much of like Kubernetes was built as a stateless system, but now with the machine learning models, code has become like in gigabytes rather than in MBs. So how that completely changes like how we need to think about deployment and DevOps, and with this new field of like whole MLOps, right? So yeah, that's pretty fascinating.
Yeah, I think that's a completely new category and also a confusing one, because you have two types of MLOps. You have AI to do the ops for you, and you have ops to do the AI. And I'm constantly confused with one of them is called AI ops and one of them is ML ops or ops ML. I keep forgetting, but and you can potentially, it can go full circle. You can have AI ops to manage the ops for the AI. I do find it interesting that we also have this exponential rise with the consumption of GPUs. What that has accelerated NVIDIA into being a giant and changed how
The most relevant company.
Yeah. I'm kind of hesitant of making that type of statement, because by the time the episode airs, it might change. But they were the most valuable, at least for at the point of this recording. They are. But I wonder if we're going to see this kind of like combine more into Kubernetes and combine more into the infrastructure that we use, because it's still very much CPU bound. It's very much CPU centric. Maybe it's the more correct term. We are starting to see more code generation, even with things like WebAssembly and other compilers that allow us to leverage GPU better. But it's still kind of on the fringes when you like go into AWS and you want to get GPU resources, or into any other cloud. You always find yourself at kind of edge cases. It's not that for example, you don't have, at least as far as I'm aware, you don't have a serverless Lambda with GPU. You need to run a dedicated EC2 instance for that. And I'm very curious to see if that will evolve, and if platforms like Hugging Face would kind of merge into our existing platform as a service, infrastructure as a service.
I think that's pretty interesting. And I think it started with the idea that I think when compute started, right, I think it all started with EC2 machines, right? Amazon EC2 was like one of the only ways you could get a machine in cloud and then deploy it. And I think it took like 5 to 7 years for people to come up with something like Lambda. And I think what Lambda does, I think, again, it's on the same computing principle of 1.0, right? So Lambda as a service is completely stateless, right? Where, let's say, if you want to remember a 20 gigabyte model, right, you can't remember it. You have to always get it from a cloud storage or like get it from a disk, wherever it's stored, right? So I think that's where I see the future. So one is, of course, the new type of compute, right, which is GPU, which does matrix multiplication like super well, right? And that's like what AI essentially is today at the like lowest level of hardware, right? Some matrices multiplying with some matrices, and then the next token gets predicted, right? So that's very fascinating. But I think along with that, I think definitely like serverless for GPU makes more sense, because I think the cost here is at like 10x more than CPUs. So I think that's a very like a whole new system of like lambdas for GPUs, which I think you'll see, and which is also something that we are trying to solve at Infosys, to like make sure that these machine learning models, which are bigger, can also start in like few seconds as a lambda would, right? Where it's like just completely, for a developer, doesn't matter if you're deployed on an EC2 machine or a lambda.
So really, if I understand correctly, we're now limited by the processing power that we can offer for these machine learning models. Because of the amount of data that they have, we can't process them fast enough. Is that correct?
Yeah, so I think one is like the compute, which is for the machine learning model. So you're completely correct in that. But second is also like for us to, let's say, use it, like any developer to use it like super fast, right? You have to right now, as Or said, like we have to get a GPU machine and then set up everything on that and do that. So having a serverless system also helps like developers do it faster, right? And for that, we need to have a lot of memorization inbuilt in the architecture, right? Where it can remember that, hey, Llama is here, or like Mistral is somewhere like on this machine, so I can just quickly get the state out.
We're still waiting for democratizing the access into machine learning models. It's happening, and more companies are offering things. They're more abstraction layers. but it's still not on par with what we have with compute. And to be honest, even what we have in compute is also still kind of annoying. We're seeing innovation there, like with companies like Vercel and Netlify and Railway. But still, when you want like heavy duty stuff, if you want a lot of significant resources, you often find yourself running a lot of YAML files in Kubernetes or configuring actual dedicated machines. And it's worse with GPU. So it would be interesting to see how this entire space evolves and how much also AI would come into play into or helping us use itself. The recursive aspect very interesting.
Yeah, how much AI will help deploy itself better so that it can become better. Yeah.
Oh yes, we're getting recursive.
Yeah.
At some point, we get into the singularity, and the AI just takes over and says, "Okay, monkeys, move away. I'll handle the rest of this infrastructure."
Yeah, and I think that's the red kill switch. I think that people say that Sam Altman probably carries in his bag. Like I think it's a hardware level red button where it's like destroy all the machines.
I think at that point it will be too late. Will be so dependent on we'll come to press on the red button and we'll discover that the red button itself is maintained by AIs and is a machine learning model that implements the pressing and everything. You're like, oh, when did that happen? Oh, we upgraded everything.
Terminator 2 goes into great detail about what happens when you try to do that.
I think tests there will be very important.
Yes.
We'll need a test to figure out what percentage of our system is currently AI and how much of it hallucinates, just to cover our basics with regression.
Yeah, no doubt. What scares me about AI is that we don't actually build it, we grow it.
Right.
And so understanding what it can and can't do is kind of scary.
To counter that, I kind of agree, but just to be contrarian for the interesting bit of it, we kind of do that with humans as well, right? and we allow them to run all of our society to our detriment, I'd say, because our new overlords would do a far better job.
Agreed.
But maybe that's not that different from what we were already doing.
That's a fair point.
It almost sounds like we've just created the perfect Black Mirror episode.
Definitely one of the scarier ones, I'd say. Well, I will also note that a Black Mirror episode that focuses more on Kubernetes or GPUs is definitely something that is missing in their set. So maybe if the authors of Black Mirror are listening, this is a request for a more developer-oriented episodes.
Yep. Probably like a AWS deploys AI to manage all the machines, and then it says that, okay, you are no longer needed. You have deployed the last commit. That would be very interesting if we see the last commit made by human. After that, no commits. It's done.
It'd be like a history thing that people would visit.
That's also an interesting concept. Archaeology in Git commits. Like you reverse, you discover history by transversing through the commits.
Oh, I like that.
So not just learning about the software, but learning about the people that wrote the software.
There actually is.
That's kind of
there actually are some people that do that, but not with Git history. But they go back to things like Atari games, and go look at the original source code, and you try to track down the original developers. Very interesting.
Well, I think we've created some good materials for new episodes. I'm going to run to an AI and tell them to just write the episodes so we can go full circle. And I think now that we went full circle at least a couple of times, we're basically in a spiral, we should circle down the drain into the end of this episode. Nilesh, James, thank you very much for coming on our show. It was a delight to have you and learning from your facts.
Good to be here. Thank you.
Like I said, Nilesh, James, it was a pleasure having you here. And to our audience, thanks for listening. And as always, we will see you in the next one.
Bye.
Bye.
I think this is the perfect time to wrap up the show. If you liked this podcast, tell your friends about it. If you didn't like it, tell your enemies about it.